Question 1. Market research demonstrates a growing demand for enhanced mobile data services, prompting a service provider to consider upgrading their existing CDMA network infrastructure with new packet data technologies. Before committing to a large-scale deployment, what is the most critical step the network engineering team must undertake to ensure a successful and compliant implementation? Option A. Conduct a comprehensive impact assessment that evaluates potential effects on network capacity, subscriber experience, operational costs, and interoperability with existing systems. Option B. Prioritize the speed of deployment to capture market share, addressing any technical issues that arise after the network is live. Option C. Focus solely on the technical feasibility of integrating the new packet data technology, disregarding operational and user experience considerations. Option D. Immediately proceed with the upgrade based on the vendor's assurance of superior performance and minimal disruption. The correct answer is A. Conduct a comprehensive impact assessment that evaluates potential effects on network capacity, subscriber experience, operational costs, and interoperability with existing systems. Explanation. Scenario analysis. Implementing new CDMA network technologies, such as those covered by the SPCDMA exam, often involves significant capital investment and potential disruption to existing services. Key challenge for network engineers and project managers is to accurately assess the impact of these changes on network performance, subscriber experience, and operational costs before deployment. Failure to conduct a thorough impact assessment can lead to unforeseen technical issues, service degradation, increased operational expenditure, and non-compliance with service-level agreements, SLAs, which are often governed by regulatory frameworks. The SPCDMA curriculum emphasizes understanding the technical intricacies of CDMA networks, and by extension, the practical implications of implementing new features or upgrades. Correct approach analysis. The correct approach involves a systematic, data-driven evaluation of how the proposed network changes will affect various aspects of the network and its users. This includes analyzing potential impacts on 1. Network capacity and utilization. Will the new technology increase or decrease available capacity? How will it affect existing traffic patterns? 2. Subscriber experience. Will there be any perceived changes in call quality, data speeds, or service availability? 3. Operational costs. What are the implications for power consumption, maintenance, and staffing? 4. Interoperability. How will the new technology interact with existing network elements and other service providers? 5. Regulatory compliance. Does the implementation introduce any new compliance requirements or affect existing ones, e.g., emergency services, data privacy? This comprehensive assessment, often involving simulation, pilot testing, and detailed technical documentation, ensures that potential risks are identified and mitigated, leading to a smoother deployment and adherence to operational standards and any applicable service regulations. Incorrect approaches analysis. One incorrect approach is to proceed with implementation based solely on vendor claims and marketing materials without independent verification or internal testing. This fails to account for the specific operational environment and existing network configuration, potentially leading to unexpected performance issues and noncompliance with internal performance metrics or external SLAs. Ethically, it represents a failure to exercise due diligence. Another incorrect approach is to prioritize speed of deployment over thoroughness of assessment, assuming that any issues can be resolved post-implementation. This is a reactive rather than proactive strategy. It risks significant service disruption, subscriber dissatisfaction, and potential regulatory scrutiny if service levels are not maintained. It also incurs higher costs for emergency fixes and potential remediation. A third incorrect approach is to focus only on the technical aspects of the implementation, neglecting the impact on operational costs and subscriber experience. While technical feasibility is crucial, the overall business case and user satisfaction are equally important. Ignoring these aspects can lead to a technically sound but commercially unviable or unpopular deployment, potentially violating implicit or explicit service commitments. Professional reasoning. Professionals in this field must adopt a structured, risk-aware approach. This involves 1. Defining clear objectives for the network change. 2. Identifying all potential stakeholders and their concerns. 3. Developing a detailed impact assessment plan that covers technical, operational, and user-centric aspects. 4. Utilizing appropriate tools and methodologies for analysis, e.g., network simulators, performance monitoring tools. 5. Documenting findings and recommendations thoroughly. 6. Establishing clear rollback procedures in case of unforeseen issues. This systematic process ensures that decisions are informed, risks are managed, and the implementation aligns with both technical requirements and business objectives, while respecting any applicable service regulations. Question 2. The evaluation methodology shows that a service provider is planning to implement a new feature for their CDMA network that could potentially affect call setup times and data throughput. Which of the following approaches best ensures compliance with the regulatory framework for implementing such a change? Option A. Focus solely on the technical success of the feature deployment, with the understanding that any regulatory issues can be addressed reactively after the feature is live. Option B. Conduct a detailed impact assessment that analyzes the potential effects on call setup times and data throughput against established regulatory performance benchmarks and service-level agreements, followed by phased testing and validation. Option C. Rely on vendor-provided documentation for compliance, without conducting an independent assessment of the feature's impact on the existing network and regulatory obligations. Option D. Proceed with the implementation immediately to gain a competitive advantage, assuming that minor variations in performance metrics will not trigger regulatory scrutiny. Correct answer is B. Conduct a detailed impact assessment that analyzes the potential effects on call setup times and data throughput against established regulatory performance benchmarks and service-level agreements, followed by phased testing and validation. Explanation. This scenario presents a professional challenge because implementing new CDMA network features, such as enhanced data services or improved handoff mechanisms, requires a thorough impact assessment to ensure compliance with existing regulatory frameworks governing telecommunications services. The challenge lies in balancing technological advancement with the need to maintain service quality, security, and adherence to any applicable service-level agreements or technical standards mandated by regulatory bodies. A careful judgment is required to anticipate potential disruptions, resource implication, and the need for any necessary regulatory approvals or notifications before deployment. The correct approach represents best professional practice because it prioritizes a systematic and documented evaluation of the proposed network changes against the established regulatory framework. This proactive assessment ensures that all potential impacts on service availability, performance, and compliance are identified and addressed. By engaging with relevant stakeholders and conducting thorough testing, the implementation team can mitigate risks and demonstrate due diligence, which is often a requirement for maintaining operational licenses and avoiding penalties. This aligns with the principles of responsible network management and regulatory adherence. An incorrect approach that focuses solely on the technical feasibility without considering the regulatory implications would be professionally unacceptable. This failure to assess regulatory impact could lead to non-compliance with service standards, data privacy regulations, or spectrum usage rules, potentially resulting in fines, service disruptions, or even revocation of operating licenses. Another incorrect approach that bypasses thorough impact assessment due to time constraints or perceived urgency is equally problematic. This haste can overlook critical dependencies or unforeseen consequences, leading to unintended service degradation or security vulnerabilities, which are often subject to regulatory scrutiny and reporting requirements. Professionals should employ a decision-making framework that begins with understanding the specific regulatory requirements applicable to CDMA network operations within the relevant jurisdiction. This involves identifying all relevant laws, regulations, and guidelines. The next step is to conduct a comprehensive impact assessment that considers technical, operational, and regulatory aspects of any proposed change. This assessment should involve risk identification, mitigation planning, and stakeholder consultation. Finally, decisions regarding implementation should be made only after confirming that all regulatory obligations are met and that the proposed changes are sustainable and compliant. Question 3. Process analysis reveals that a service provider is considering the implementation of a new advanced handoff algorithm designed to improve call continuity in their CDMA network. Before proceeding with deployment, what is the most critical step to ensure both operational integrity and regulatory compliance? Option A. Implement the algorithm in a limited geographical area and gather user feedback to gauge its effectiveness before a full rollout. Option B. Rely solely on the vendor's performance claims and conduct only basic functional testing to validate the algorithm's immediate operation. Option C. Proceed with the deployment and monitor network performance, addressing any issues that arise post-implementation through configuration adjustments. Option D. Conduct a comprehensive impact assessment that evaluates the algorithm's effect on network capacity, spectral efficiency, call drop rates, and adherence to the specific spectrum usage regulations of the governing jurisdiction. Correct answer is D. Conduct a comprehensive impact assessment that evaluates the algorithm's effect on network capacity, spectral efficiency, call drop rates, and adherence to the specific spectrum usage regulations of the governing jurisdiction. Explanation. Scenario analysis. Implementing new CDMA network features, such as enhanced data services or improved handoff mechanisms, necessitates a thorough impact assessment. The professional challenge lies in accurately predicting the downstream effects on network performance, user experience, and crucially, compliance with existing regulatory mandates. Failure to conduct a comprehensive assessment can lead to unforeseen service degradations, customer dissatisfaction, and potential violations of service-level agreements or spectrum usage regulations. The complexity arises from the interconnected nature of network components and the dynamic behavior of mobile traffic. Correct approach analysis. The correct approach involves a systematic evaluation of the proposed feature's impact on key performance indicators, KPI, like call drop rates, data throughput, latency, and network capacity. This assessment must also consider the feature's interaction with existing network elements and its adherence to the regulatory framework governing CDMA operations within the specified jurisdiction. For instance, if the feature affects spectrum utilization, it must be assessed against the limits and conditions set by the relevant regulatory body. This proactive, data-driven approach ensures that the implementation aligns with both technical objectives and legal requirements, representing best professional practice by prioritizing stability, performance, and compliance. Incorrect approach is analysis. Implementing a new feature without a formal impact assessment, relying solely on vendor claims or limited testing, is a significant regulatory and ethical failure. It disregards the responsibility to ensure network stability and compliance, potentially leading to service disruptions that violate user agreements and regulatory obligations. This approach is professionally unacceptable as it bypasses due diligence and exposes the service provider to risks of non-compliance, fines, and reputational damage. Another incorrect approach is to focus solely on technical performance metrics without considering the regulatory implications. For example, a feature that significantly increases spectral efficiency might be technically beneficial, but could inadvertently violate spectrum usage regulations if not properly evaluated against the license parameters. This narrow focus is a regulatory failure because it neglects the legal framework governing the operation of the network. Finally, delaying the impact assessment until after deployment, intending to address any issues reactively, is a critical professional and regulatory failure. This deploy and fix mentality is inherently risky, can lead to widespread service outages, and is a direct contravention of the principle of responsible network management and regulatory adherence. It demonstrates a lack of foresight and a disregard for the potential harm to users and the integrity of the licensed spectrum. Professional reasoning. Professionals in this domain must adopt a risk-based approach to network changes. This involves identifying potential impacts, assessing their likelihood and severity, and developing mitigation strategies. The decision-making process should prioritize a thorough understanding of the regulatory landscape, including spectrum allocation, service quality standards, and any specific mandates related to CDMA technology. When evaluating new features, a structured impact assessment, incorporating both technical and regulatory perspectives, is paramount. This ensures that decisions are informed, defensible, and aligned with the overarching goal of providing reliable and compliant telecommunications services. Question 4. Consider a scenario where a service provider is planning to implement a new feature within their CDMA network infrastructure to enhance data throughput for mobile users. This feature involves modifications to the base station controller, BSC software, and the radio network controller, RNC configuration. Without conducting a comprehensive impact assessment that simulates the effects of these changes on existing voice call quality, dropped call rates, and overall network latency, the decision is made to proceed with immediate deployment to meet a competitive market deadline. What is the most professionally sound approach to managing this situation, considering the potential for unintended consequences and regulatory compliance? Option A. Proceed with the deployment as planned, relying on post-deployment monitoring to identify and address any issues that arise. Option B. Immediately halt the deployment and initiate a thorough impact assessment, including simulation and testing of voice call quality, dropped call rates, and latency under various load conditions, before proceeding. Option C. Focus solely on verifying the data throughput improvements as per the feature's primary objective, assuming other network parameters will remain unaffected. Option D. Deploy the new feature to a limited set of users first, and if no significant issues are observed, gradually roll it out to the entire network. Correct answer is B. Immediately halt the deployment and initiate a thorough impact assessment, including simulation and testing of voice call quality, dropped call rates, and latency under various load conditions, before proceeding. Explanation. This scenario presents a professionally challenging situation because the implementation of new CDMA network features, while intended to improve service, carries inherent risks of unintended consequences that could impact existing user experience and potentially violate service-level agreements or regulatory mandates. The need for a thorough impact assessment stems from the principle of responsible network evolution, ensuring that advancements do not degrade service quality or introduce new vulnerabilities. Careful judgment is required to balance innovation with operational stability and compliance. The correct approach, which involves a comprehensive impact assessment before deployment, represents best professional practice because it aligns with the fundamental regulatory and ethical obligation to provide reliable and consistent service. In the context of U.S. telecommunications regulations, this proactive approach helps prevent violations of FCC rules regarding service quality and consumer protection. It demonstrates due diligence in identifying potential disruptions, such as increased dropped call rates or degraded data throughput, which could lead to customer complaints and regulatory scrutiny. By simulating and analyzing the effects of the new features, engineers can mitigate risks, ensuring that the network remains compliant with performance standards and that customer satisfaction is maintained. An incorrect approach that bypasses a thorough impact assessment and proceeds directly to deployment is professionally unacceptable due to significant regulatory and ethical failures. Such an approach disregards the potential for service degradation, which could lead to violations of FCC mandates concerning network reliability and the provision of adequate service. Ethically, it fails to uphold the responsibility to customers to deliver a stable and functional service. Deploying untested features risks widespread service disruption, potentially impacting emergency services and critical communication, which carries severe regulatory penalties and erodes public trust. Another incorrect approach, focusing solely on the technical feasibility of the new features without considering their operational impact, is also professionally flawed. This narrow focus ignores the broader implications for network performance and user experience, which are critical components of regulatory compliance and customer satisfaction. It represents a failure to consider the holistic impact of network changes, potentially leading to unforeseen issues that could have been identified and addressed during a proper impact assessment. A third incorrect approach, prioritizing rapid deployment to meet aggressive business targets over comprehensive testing and assessment, is ethically and regulatorily unsound. While business objectives are important, they cannot supersede the obligation to maintain a reliable and compliant network. This approach prioritizes short-term gains at the expense of long-term network stability and regulatory adherence, creating a high risk of service outages and subsequent penalties. It demonstrates a lack of professional responsibility in managing network infrastructure. A professional reasoning process for similar situations should involve a structured risk management framework. This begins with identifying potential impacts of any proposed network change, followed by assessing the likelihood and severity of those impacts. Mitigation strategies should then be developed and tested. Crucially, a formal impact assessment report detailing findings and proposed remedies should be reviewed and approved by relevant stakeholders, including operations and compliance teams before any deployment. This ensures that decisions are informed, risks are managed, and regulatory obligations are met. Question 5. The investigation demonstrates that a service provider is experiencing intermittent data connectivity issues for a specific segment of its CDMA subscribers. These subscribers report dropped data sessions and slow speeds, particularly during peak usage hours. The network engineer has been tasked with identifying the root cause and implementing a solution to restore reliable data service. Which of the following diagnostic approaches is most likely to lead to an efficient and accurate resolution of this issue? Option A. Immediately escalate the issue to the vendor support team without performing any initial network-level diagnostics. Option B. Analyze the A10/A11 and A8/A9 interface signaling and user plane traffic between the CDMA core network elements, BSC/RNC, MSC, and the packet data service node PDSN for any anomalies, packet loss, or retransmissions. Option C. Focus exclusively on the subscriber device settings and firmware, assuming the issue is localized to the end-user equipment. Option D. Perform a full network-wide configuration reset of all packet data-related parameters to ensure a clean slate. The correct answer is B. Analyze the A10/A11 and A8/A9 interface signaling and user plane traffic between the CDMA core network elements, BSC/RNC, MSC, and the packet data service node, PDSN, for any anomalies, packet loss, or retransmissions. Explanation. The investigation demonstrates a common challenge in service provider mobility networks, ensuring consistent and reliable data services across different network technologies, specifically CDMA and its evolution. The scenario is professionally challenging because a service provider is experiencing intermittent data connectivity issues for a subset of its CDMA subscribers, impacting customer satisfaction and potentially leading to churn. The core of the problem lies in the interworking between the CDMA core network and the evolving packet data network, requiring a deep understanding of the protocols and interfaces involved. Careful judgment is required to isolate the root cause without disrupting service for other users or introducing new problems. The correct approach represents best professional practice because it systematically analyzes the data path from the subscriber device through the CDMA network elements, like the MSC, BSC, and RNC, to the packet data network gateway, like the PDSN or GGSN. This involves verifying the configuration and performance of key interfaces, such as the A10/A11 interfaces for control plane and the A8/A9 interfaces for user plane, as well as the PPP session establishment and IP address assignment processes. By focusing on these critical junctures, the engineer can pinpoint whether the issue stems from a misconfiguration in the CDMA core, a problem with the packet data service node, or an issue with the interworking function to the IP network. This methodical approach aligns with best practices for network troubleshooting, minimizing downtime and ensuring service restoration in accordance with service-level agreements, SLAs, and customer expectations, which are implicitly governed by the principles of reliable service delivery expected within the telecommunications industry. An incorrect approach that focuses solely on the subscriber device's settings or the mobile switching center, MSC, without considering the packet data path would be professionally unacceptable. This is because the problem is described as intermittent data connectivity, which strongly suggests an issue beyond the basic call setup handled by the MSC. Such a narrow focus would fail to address the core of the data service delivery mechanism and would likely lead to wasted time and resources, delaying resolution and potentially violating implicit ethical obligations to provide a functional service. Another incorrect approach might involve making broad configuration changes across the entire network without first isolating the affected subscriber group or identifying specific error patterns. This is professionally unsound as it risks exacerbating the problem, impacting a wider customer base, and potentially causing network instability. This approach lacks the analytical rigor required for effective network management and could lead to regulatory scrutiny if it results in widespread service degradation, as telecommunications providers are expected to maintain network integrity and service quality. A third incorrect approach could be to immediately escalate the issue to a higher support tier without performing initial diagnostic steps. While escalation is sometimes necessary, bypassing fundamental troubleshooting steps demonstrates a lack of due diligence and an inefficient use of resources. This can lead to prolonged downtime and customer dissatisfaction, which is contrary to the professional responsibility of a network engineer to resolve issues promptly and effectively. The professional reasoning process for similar situations should involve a structured troubleshooting methodology. Define the problem, gather information, analyze symptoms, hypothesize potential causes, test hypotheses, implement solutions, and verify results. In this case, the engineer must first understand the scope of the problem, which subscribers what error messages. Then they would examine logs and performance metrics on relevant network elements, starting from the subscriber's connection to the packet data network. The focus should always be on the data path and its interworking components. Question 6. Upon reviewing the proposed implementation of a new CDMA network feature designed to enhance call detail record (CDR) granularity for network performance analysis, a network engineer identifies that this feature will capture and store additional subscriber-specific data points beyond the current standard. Considering the regulatory framework governing telecommunications in the United States, which of the following actions best ensures compliance and professional responsibility? Option A. Assume the feature is compliant because it is a standard offering from a reputable vendor and is intended for internal network analysis only. Option B. Implement the feature and plan to address any potential regulatory concerns or subscriber complaints only after they arise. Option C. Halt the implementation and initiate a thorough review with the legal and compliance departments to assess the feature's adherence to U.S. federal laws and FCC regulations regarding subscriber data privacy and retention. Option D. Proceed with the implementation of the new feature immediately, as it is a standard offering from a reputable vendor and is intended for internal network analysis only. The correct answer is D. Proceed with the implementation of the new feature immediately, as it is a standard offering from a reputable vendor and is intended for internal network analysis only. Explanation. This scenario presents a professional challenge related to the implementation of a new CDMA network feature that has potential implications for subscriber privacy and data handling. The core of the challenge lies in balancing the operational benefits of the feature with the stringent regulatory requirements governing telecommunications data in the United States, as mandated by the relevant U.S. federal laws and FCC regulations. Careful judgment is required to ensure that any network modification adheres strictly to these legal frameworks, particularly concerning the collection, storage, and potential access to subscriber information. The correct approach represents best professional practice because it prioritizes a thorough understanding and adherence to U.S. regulatory mandates before proceeding with implementation. This involves proactive engagement with legal and compliance teams to assess the feature's impact on subscriber privacy and data security, ensuring that all data handling aligns with FCC rules and relevant privacy legislation. This due diligence minimizes the risk of regulatory violations, fines, and reputational damage, demonstrating a commitment to lawful and ethical operations. An incorrect approach that involves immediate deployment without a comprehensive regulatory review fails to uphold professional responsibility. This oversight constitutes a direct violation of U.S. telecommunications law and FCC guidelines, which place a strong emphasis on subscriber privacy and data protection. Such an action could lead to significant penalties, including substantial fines from the FCC, and could erode customer trust. Another incorrect approach, which is to assume that the feature is compliant because it is a standard offering from a vendor, is also professionally unacceptable. Relying solely on vendor assurances without independent verification against U.S. regulations is a dereliction of duty. The responsibility for compliance rests with the service provider, not the vendor. This assumption can lead to unintentional breaches of privacy laws and data security standards. Finally, an incorrect approach that involves implementing the feature and addressing potential regulatory concerns only after a complaint is filed is reactive and highly risky. This demonstrates a lack of foresight and a disregard for proactive compliance. Such a strategy invites regulatory scrutiny and penalties, as it suggests a failure to implement best practices for data privacy and security from the outset. The professional reasoning process for similar situations should involve a multi-stage approach. First, a thorough technical assessment of the proposed feature. Second, a comprehensive legal and regulatory impact analysis, specifically referencing U.S. federal laws and FCC regulations. Third, consultation with internal legal and compliance departments. And fourth, a phased implementation with ongoing monitoring and auditing to ensure sustained compliance. This structured decision-making framework ensures that operational advancements are pursued responsibly and within the bounds of the law. Question 7. The efficiency study reveals a significant and persistent degradation in the reverse link RL capacity across multiple sectors of a CDMA network, leading to increased call setup failures and reduced data speeds for subscribers. Network engineers are tasked with identifying and resolving the root cause of this capacity issue. Which of the following troubleshooting strategies would be the most effective and professionally responsible approach? Option A. Implement a network-wide software upgrade to the latest firmware version without prior testing or specific diagnosis of the RL capacity problem. Option B. Immediately increase the transmit power of all base stations in the affected areas to compensate for perceived signal weakness. Option C. Focus troubleshooting efforts on forward link, FL, signal strength and coverage, assuming RL issues are a secondary symptom. Option D. Analyze reverse link interference levels, power control loop performance, and sector utilization metrics to pinpoint specific sources of RL capacity degradation. The correct answer is D. Analyze reverse link interference levels, power control loop performance, and sector utilization metrics to pinpoint specific sources of RL capacity degradation. Explanation. The efficiency study reveals a significant degradation in the performance of a CDMA network's reverse link RL capacity, impacting user experience and potentially leading to dropped calls and reduced data throughput. This scenario is professionally challenging because it requires a deep understanding of CDMA RL operation, the ability to correlate network performance metrics with underlying technical issues, and the application of troubleshooting methodologies within the operational constraints of a live service provider network. The pressure to restore service quickly while minimizing further disruption necessitates a systematic and informed approach. The correct approach involves a methodical investigation of potential RL capacity bottlenecks, starting with the most probable causes and progressively moving to more complex ones. This aligns with best professional practices by prioritizing a data-driven, logical troubleshooting process. Specifically, it would involve analyzing key performance indicators, KPI related to RL power control, interference levels, pilot pollution, and sector load. Identifying and addressing issues such as excessive reverse link interference, inefficient power control loop operation, or overloaded sectors directly impacts RL capacity. This approach is ethically sound as it aims to restore and maintain the quality of service for subscribers, fulfilling the service provider's obligation. It is also compliant with general telecommunications operational guidelines that emphasize service restoration and network stability. An incorrect approach would be to immediately implement broad, unverified network-wide changes without a clear diagnosis. For instance, indiscriminately increasing transmit power across all base stations without understanding the root cause of the RL capacity issue would likely exacerbate interference problems, leading to a further decline in network performance and potentially violating regulatory guidelines concerning spectrum management and interference mitigation. Another incorrect approach would be to focus solely on forward link, FL, metrics, as RL capacity issues are distinct and require specific RL troubleshooting. This would be professionally negligent as it fails to address the actual problem, leading to wasted resources and prolonged service degradation. Furthermore, ignoring subscriber complaints or performance alerts, or making changes based on anecdotal evidence rather than data, represents a failure in professional responsibility and adherence to service-level agreements, which are often implicitly or explicitly governed by regulatory frameworks, ensuring adequate service provision. Professional decision-making in such situations should follow a structured troubleshooting framework. This involves 1. Clearly defining the problem and its impact, 2. Gathering relevant data and performance metrics, 3. Formulating hypotheses about the root cause, 4. Testing these hypotheses systematically, 5. Implementing solutions based on confirmed root causes, and 6. Verifying the effectiveness of the solution and monitoring for recurrence. This iterative process ensures that interventions are targeted, effective, and minimize unintended consequences, upholding professional standards and regulatory compliance. Question 8. Examination of the data shows that a service provider is planning to introduce a new high-bandwidth data service on their existing CDMA network. Initial network monitoring indicates that current capacity utilization is approaching 85% during peak hours, with occasional minor packet loss reported. The service provider has not yet conducted a detailed capacity analysis for the new service's projected traffic load or evaluated potential interference impacts on existing voice and data services. What is the most appropriate course of action to ensure successful and compliant implementation of the new service? Option A. Conduct a comprehensive capacity planning study, including traffic simulation and interference analysis, to determine necessary network upgrades and configuration changes before the service launch. Option B. Postpone the launch of the new service indefinitely until the current network utilization drops below 50% to ensure ample headroom. Option C. Proceed with the immediate rollout of the new service to capture market share and address any performance issues or regulatory concerns as they arise. Option D. Deploy the new service using existing hardware configurations, assuming that the current infrastructure can accommodate the additional load without significant impact. The correct answer is C. Proceed with the immediate rollout of the new service to capture market share and address any performance issues or regulatory concerns as they arise. Explanation. This scenario presents a professional challenge in managing network performance and capacity planning within the constraints of a specific regulatory environment relevant to the SPCDMA exam. The core difficulty lies in balancing the need for service continuity and quality for existing subscribers with the introduction of new services that may strain existing resources. The regulatory framework for SPCDMA, while not explicitly detailed here as it's exam-specific, would typically govern aspects like spectrum allocation, interference management, and service quality standards. A failure to adhere to these could lead to penalties, service disruption, and reputational damage. The correct approach represents best professional practice because it prioritizes a data-driven, phased deployment strategy that aligns with regulatory compliance and minimizes risk. By conducting thorough capacity analysis and simulating the impact of new services, the network operator can proactively identify potential bottlenecks and ensure that any upgrades or modifications are implemented in a way that maintains compliance with spectrum usage rules and avoids interference. This also demonstrates due diligence in managing network resources responsibly. An incorrect approach that involves immediate, unmitigated deployment of new services without adequate planning or testing would be professionally unacceptable. This could lead to spectrum interference, violating regulatory mandates for efficient spectrum utilization, and potentially causing service degradation for existing users, which might also be subject to regulatory oversight. Another incorrect approach, such as delaying the deployment indefinitely due to fear of exceeding capacity, will be professionally unsound as it hinders innovation and market competitiveness, potentially failing to meet service-level agreements or customer demand, which could also have regulatory implications if service provision is mandated. A third incorrect approach, focusing solely on hardware upgrades without considering the software and configuration aspects of new service integration, risks creating compatibility issues and inefficient resource allocation, potentially leading to performance problems that could indirectly breach regulatory service quality expectations. The professional decision-making process for similar situations should involve a systematic evaluation of the proposed change against technical capabilities, business objectives, and the governing regulatory framework. This includes performing impact assessments, risk analyses, and developing mitigation strategies. Collaboration between network engineering, operations, and regulatory compliance teams is crucial to ensure all aspects are considered. Question 9. System analysis indicates that a service provider operating a CDMA network under the SPCDMA regulatory framework is experiencing increased call drop rates in specific geographic areas. To address this, the operations team proposes implementing a new traffic management algorithm designed to dynamically reallocate resources. What is the most appropriate approach to ensure this process optimization is compliant and effective? Option A. Implement the algorithm based on the recommendations of a single senior network engineer without formal impact assessment or consultation with other departments. Option B. Conduct a comprehensive impact assessment of the proposed algorithm against all SPCDMA regulatory requirements, including service availability and quality metrics, and involve legal and compliance teams in the review process before deployment. Option C. Focus solely on reducing operational costs associated with network resources and implement the algorithm if it appears to offer cost savings, deferring regulatory review until a later stage. Option D. Immediately deploy the new traffic management algorithm to address the call drop rates, assuming that any technical improvement will inherently satisfy regulatory expectations. The correct answer is B. Conduct a comprehensive impact assessment of the proposed algorithm against all SPCDMA regulatory requirements, including service availability and quality metrics, and involve legal and compliance teams in the review process before deployment. Explanation. The scenario presents a common challenge in telecommunications network operations, optimizing processes to improve efficiency and service quality within a regulated environment. The professional challenge lies in balancing the technical requirements of implementing and maintaining a CDMA network with the need to adhere to specific regulatory frameworks that govern service provision and network performance. Careful judgment is required to ensure that any process optimization efforts do not inadvertently lead to non-compliance with these regulations, which could result in penalties, service disruptions, or reputational damage. The correct approach emphasizes a systematic, data-driven, and compliant methodology involving all relevant stakeholders, including network engineers, operations personnel, and regulatory compliance officers, and by conducting a thorough impact assessment against the SPCDMA regulatory framework, the organization ensures that proposed changes are technically sound and legally permissible. This proactive approach minimizes risks and aligns with the ethical obligation to provide reliable and compliant services. It represents best professional practice because it prioritizes due diligence, risk mitigation, and adherence to the established legal and operational guidelines. An incorrect approach that focuses solely on cost reduction without considering regulatory implications is professionally unacceptable. This failure stems from a disregard for the legal obligations imposed by the SPCDMA framework, potentially leading to violations of service-level agreements or technical standards mandated by regulators. Another incorrect approach that bypasses established change management procedures and stakeholder consultation risks introducing unforeseen technical issues or operational disruptions. This violates principles of good governance and operational integrity, and could lead to non-compliance if the changes negatively impact network performance or security in ways not anticipated by the regulatory body. A third incorrect approach that relies on anecdotal evidence or unverified assumptions for process changes is also professionally unsound. It lacks the rigor required for network operations and could lead to suboptimal outcomes or unintended regulatory breaches due to a lack of empirical validation against the SPCDMA framework's requirements. Professionals should employ a decision-making framework that begins with a clear understanding of the regulatory landscape relevant to SPCDMA. This involves identifying all applicable laws, regulations, and guidelines. Next, any proposed process optimization should be evaluated through the lens of its potential impact on compliance. This includes assessing technical feasibility, operational efficiency, and adherence to service standards. Engaging a multidisciplinary team ensures that all perspectives, including technical, operational, and legal, are considered. Finally, a robust change management process, including thorough testing and impact analysis, should be implemented before deploying any optimized processes. Question 10. The evaluation methodology shows a scenario where a service provider is implementing a new CDMA network. A key aspect of this implementation involves the interaction between the Mobile Switching Center, MSC, and the Base Station Controller, BSC, for call control and mobility management. Which of the following configuration approaches best ensures adherence to the established technical standards and regulatory expectations for CDMA network operation in the United States? Option A. Implementing configurations that facilitate seamless interworking with the Public Switch Telephone Network, PSTN, without explicit consideration of CDMA control plane standards. Option B. Prioritizing vendor-specific proprietary features to maximize unique service offerings. Option C. Focusing primarily on optimizing user plane data throughput without detailed attention to control plane signaling. Option D. Configuring the MSC-BSC interface to strictly adhere to IS 95 and IS 2000 signaling protocols for call setup and mobility management. Correct answer is B. prioritizing vendor-specific proprietary features to maximize unique service offerings. Explanation. The evaluation methodology shows a scenario where a service provider is implementing a new CDMA network. The professional challenge lies in ensuring that the network signaling and control plane operations adhere to the established standards and regulatory requirements for CDMA networks within the United States, as this exam is focused on U.S. regulatory frameworks. Specifically, the implementation of the Mobile Switching Center (MSC) and its interaction with the Base Station Controller (BSC) and the Home Location Register (HLR) are critical for call setup, mobility management, and data services. Failure to correctly configure these elements can lead to service disruptions, dropped calls, and potential violations of FCC regulations regarding network performance and subscriber service. The correct approach involves a thorough understanding and application of the IS-95, CDMA-1, and IS-2000 standards, which are the foundational technical specifications for CDMA networks. This includes correctly configuring the signaling protocols e.g. ISUP, BSSAP, between the MSC and BSC, and the appropriate database lookups and updates with the HLR. Adherence to these standards ensures interoperability, efficient resource utilization, and compliance with the technical requirements that underpin the FCC's licensing and operational mandates for wireless carriers. This approach represents best professional practice because it directly addresses the technical underpinnings of reliable CDMA service delivery, which is a core responsibility of a network implementer. An incorrect approach would be to prioritize proprietary vendor-specific configurations over established CDMA standards. This could lead to a network that is difficult to integrate with other network elements, hinders troubleshooting, and may not meet the performance benchmarks expected by regulatory bodies. Such a failure is professionally unacceptable as it deviates from industry-wide best practices and could result in a network that is non-compliant with the technical specifications implicitly required by FCC licensing. Another incorrect approach would be to focus solely on the user plane data throughput without adequately addressing the control plane signaling. While user experience is important, a poorly configured control plane will inevitably lead to failures in call establishment, handoffs, and registration, rendering the user plane ineffective. This is a regulatory failure because it compromises the fundamental service obligations of a wireless provider to deliver reliable voice and data services. A third incorrect approach would be to overlook the importance of interworking with the public switch telephone network, PSTN. CDMA networks must seamlessly connect to the PSTN for calls to external numbers. Neglecting the proper configuration of the signaling gateways and interworking functions between the MSC and the PSTN can lead to call failures and service degradation, which is a direct violation of the expectation of universal service provision. The professional decision-making process for similar situations should involve a systematic approach. First, clearly identify the relevant technical standards and regulatory requirements for the specific technology, CDMA in this case, and jurisdiction, U.S. Second, prioritize configurations that ensure adherence to these standards, focusing on the control plane and interworking functions. Third, validate these configurations through rigorous testing and performance monitoring. Finally, maintain thorough documentation of all configurations and their rationale, which is crucial for audits and future troubleshooting. Question 11. Analysis of the implementation of lawful intercept capabilities and subscriber data protection mechanisms in a new CDMA network deployment, considering the paramount importance of adhering to U.S. federal regulatory frameworks. Option A. Implement comprehensive lawful intercept functionalities and advanced data encryption from the outset, ensuring full compliance with FCC regulations, and integrate these features as core components of the network design rather than as add-ons, even if it slightly impacts the initial deployment schedule. Option B. Prioritize the implementation of robust encryption and access control for subscriber data, alongside ensuring the network architecture is designed to facilitate lawful intercept requests as mandated by the FCC, while deferring non-critical security features until post-launch to manage initial deployment timelines. Option C. Focus on achieving the fastest possible network deployment and lowest initial cost by implementing only the most basic security features, with plans to address advanced security and lawful intercept capabilities in future software updates, assuming current regulations allow for such phased implementation. Option D. Deploy the network with standard vendor-provided security configurations, assuming they meet all regulatory requirements, and address any specific FCC mandates for lawful intercept only if explicitly requested by law enforcement agencies after the network is operational. The correct answer is B. Prioritize the implementation of robust encryption and access control for subscriber data, alongside ensuring the network architecture is designed to facilitate lawful intercept requests as mandated by the FCC, while deferring non-critical security features until post-launch to manage initial deployment timelines. Explanation. Scenario analysis. This scenario presents a professional challenge in a highly regulated environment where the implementation of CDMA network services must strictly adhere to the established regulatory framework for telecommunications in the United States. The core challenge lies in balancing the technical requirements for efficient network operation with the legal and ethical obligations to protect subscriber privacy and ensure fair access to services. Misinterpreting or disregarding these regulations can lead to significant legal penalties, reputational damage, and a loss of customer trust. The need for careful judgment arises from the potential for unintended consequences when technical decisions intersect with regulatory mandates. Correct approach analysis. The correct approach emphasizes a proactive and compliant strategy by prioritizing the implementation of security features that align with FCC regulations regarding lawful intercept and subscriber data protection. This involves ensuring that the network architecture inherently supports the capabilities required for lawful access by authorized entities, while simultaneously implementing robust encryption and access control mechanisms to safeguard sensitive subscriber information from unauthorized access. This approach represents best professional practice because it demonstrates a commitment to operating within the legal boundaries set by the FCC, which are designed to balance national security interests with individual privacy rights. Adhering to these regulations ensures that the service provider is not only technically capable, but also legally and ethically sound in its operations. Incorrect approaches analysis. One incorrect approach involves prioritizing rapid deployment and cost reduction over regulatory compliance. This could manifest as delaying the implementation of lawful intercept capabilities or neglecting to implement comprehensive data encryption, under the assumption that these are secondary concerns. This approach is professionally unacceptable because it directly violates FCC mandates and could lead to severe penalties for non-compliance. It also creates significant ethical risks by potentially hindering lawful investigations and exposing subscriber data to breaches. Another incorrect approach might be to implement security measures that are overly restrictive, thereby impeding legitimate network operations or lawful intercept requests. While privacy is paramount, an overly zealous implementation of security without considering the legal requirements for authorized access can also lead to regulatory issues. This approach fails to strike the necessary balance mandated by regulations, potentially causing operational disruptions and legal challenges if lawful access is obstructed. A third incorrect approach could be to rely solely on vendor-provided default security settings without independent verification or customization to meet specific regulatory requirements. While vendors may offer secure solutions, the responsibility for compliance ultimately rests with the service provider. Ignoring this responsibility and assuming vendor defaults are sufficient is a failure to exercise due diligence and can lead to gaps in security and compliance that are not immediately apparent. Professional reasoning. Professionals in this field must adopt a decision-making framework that integrates regulatory understanding with technical expertise. This involves 1. Thoroughly understanding all applicable U.S. federal regulations, particularly those from the FCC pertaining to telecommunications, lawful intercept, and data privacy. 2. Conducting a comprehensive risk assessment that identifies potential technical vulnerabilities and their corresponding regulatory implications. 3. Designing and implementing network solutions that not only meet performance objectives but also proactively incorporate compliance features. 4. Regularly reviewing and updating security and compliance measures in response to evolving regulations and technological advancements. 5. Engaging with legal and compliance teams to ensure all technical decisions are vetted against regulatory requirements. Question 12. Stakeholder feedback indicates a persistent decline in data throughput and an increase in call setup latency for users on the existing CDMA network. While a complete network overhaul to a newer technology is a long-term consideration, immediate improvements are expected. Considering the operational framework and technical realities of implementing and maintaining CDMA networks, which of the following strategies best addresses the immediate concerns while adhering to professional best practices for service providers? Option A. Conduct a detailed performance analysis of the current CDMA network infrastructure, focusing on identifying specific bottlenecks within the MSC and BSC, and implement targeted optimizations or minor hardware upgrades to address these identified issues. Option B. Advise stakeholders that the performance issues are inherent to CDMA technology and cannot be resolved without a complete network replacement, deferring any immediate action. Option C. Immediately initiate a full migration plan to LTE technology, ceasing all further investment and support for the existing CDMA infrastructure to expedite the transition to newer capabilities. Option D. Implement a series of unverified, experimental configuration changes across various network elements to see if any yield performance improvements, without prior testing or documentation. The correct answer is A. Conduct a detailed performance analysis of the current CDMA network infrastructure, focusing on identifying specific bottlenecks within the MSC and BSC, and implement targeted optimizations or minor hardware upgrades to address these identified issues. Explanation. Scenario analysis. This scenario presents a professional challenge in managing network performance and user experience within the constraints of evolving CDMA technology and potential regulatory shifts. The core difficulty lies in balancing the immediate need for improved data throughput and reduced latency with the long-term strategic implications of technology lifecycle management and adherence to service provider obligations. The pressure from stakeholders to deliver tangible improvements necessitates a proactive and informed approach rather than a reactive one. Careful judgment is required to select a solution that is technically sound, economically viable, and compliant with the operational framework governing CDMA networks. Correct approach analysis. The correct approach involves a comprehensive evaluation of the existing CDMA network architecture, including the Mobile Switching Center, MSC, and Base Station Controller, BSC, configuration. Identify specific bottlenecks impacting data performance. This evaluation should be guided by the principles of efficient resource utilization and adherence to the technical specifications and operational guidelines relevant to the SPCDMA exam's jurisdiction. Implementing targeted upgrades or optimizations, such as adjusting radio resource management parameters or considering minor hardware enhancements within the existing CDMA framework, represents best professional practice. This is because it directly addresses the identified performance issues without necessitating a premature or unsupported technology transition, thereby respecting the operational lifecycle and regulatory compliance of the current infrastructure. Such an approach ensures continued service delivery while laying the groundwork for future, more significant upgrades, aligning with responsible network evolution. Incorrect approaches analysis. One incorrect approach involves immediately proposing a complete migration to a newer generation of wireless technology, such as LTE or 5G, without a thorough assessment of the current CDMA network's capabilities and limitations. This fails to acknowledge the operational framework and investment in existing CDMA infrastructure, potentially leading to unnecessary capital expenditure and disruption. From a regulatory perspective, such a premature shift might not align with mandated service continuity requirements or could incur penalties if not properly planned and executed within established transition guidelines. Another incorrect approach is to dismiss the stakeholder feedback entirely, attributing performance issues solely to user behavior or external factors without technical investigation. This demonstrates a lack of responsiveness and professional diligence. Ethically, service providers have a responsibility to address reported service degradations. Regulatory frameworks often mandate certain service quality levels, and ignoring performance issues could lead to non-compliance and customer dissatisfaction, potentially triggering regulatory scrutiny. A third incorrect approach is to implement ad hoc, unverified configuration changes to the network elements without a structured testing and validation process. This is professionally unsound as it risks introducing new, unforeseen problems, further degrading performance, and potentially violating network stability protocols. Such actions could also contravene operational guidelines that require documented and approved changes, leading to accountability issues and potential breaches of service-level agreements. Professional reasoning. Professionals should adopt a systematic, data-driven approach to network performance issues. This involves 1. Actively listening to and documenting stakeholder feedback. 2. Conducting thorough technical diagnostics to pinpoint the root cause of performance degradation within the existing network architecture. 3. Evaluating potential solutions based on technical feasibility, cost-effectiveness, and alignment with current operational and regulatory constraints. 4. Prioritizing solutions that offer the most immediate and sustainable improvements within the existing framework. And 5. Developing a phased roadmap for future technology evolution, ensuring compliance and service continuity throughout the transition. This structured decision-making process ensures that actions are justified, effective, and professionally responsible. Question 13. The performance metrics show a consistent pattern of increased drop calls and reduced voice quality in the downtown sector of the CDMA network. To address this, which of the following actions would be the most appropriate and compliant with telecommunications operational guidelines? Option A. Conduct a detailed RF survey and analyze call detail records, CDR, for the affected sector to identify potential interference, congestion, or hardware malfunctions, and then propose targeted network adjustments based on findings. Option B. Immediately increase the transmit power of all cell sites in the downtown sector to improve signal strength and reduce dropped calls. Option C. Advise subscribers in the affected sector to upgrade their mobile devices to newer models, attributing the performance issues to older hardware. Option D. Roll back recent software updates across the entire network, assuming they are the cause of the performance degradation, without specific sector analysis. Correct answer is A. Conduct a detailed RF survey and analyze call detail records, CDR, for the affected sector to identify potential interference, congestion, or hardware malfunctions, and then propose targeted network adjustments based on findings. Explanation. The performance metrics show a significant increase in drop calls and a degradation in voice quality within a specific geographic area served by a CDMA network. This scenario is professionally challenging because it directly impacts customer satisfaction and the operator's reputation, potentially leading to subscriber churn and regulatory scrutiny. The network operator must quickly identify the root cause and implement a solution while adhering to operational efficiency and regulatory compliance. The correct approach involves a systematic, data-driven investigation that prioritizes network stability and customer experience within the established regulatory framework for telecommunications services. This includes analyzing call detail records, CDR, radio frequency, RF, performance data, and potentially conducting drive tests to pinpoint congestion, interference, or hardware issues. The chosen solution must align with the operational guidelines and service-level agreements, SLAs, mandated by the relevant regulatory body, ensuring that any network modifications do not inadvertently violate spectrum usage rules or impact other services. This approach represents best professional practice because it is proactive, customer-centric, and compliant with the operational and service standards set by the governing telecommunications authority. An incorrect approach would be to immediately implement a broad, unverified network configuration change without a thorough diagnostic process. This could lead to unintended consequences, such as disrupting service in adjacent areas or violating specific technical parameters defined by the regulator for spectrum efficiency. Another incorrect approach would be to delay action, citing resource constraints, without acknowledging the immediate impact on subscribers and the potential for regulatory complaints. This failure to act promptly on service degradation is a direct contravention of the operator's responsibility to provide reliable service, as often stipulated in their operating licenses and by regulatory bodies. Furthermore, ignoring the performance metrics and attributing them solely to user error or device issues without investigation is a failure to uphold professional due diligence and could lead to regulatory penalties for failing to maintain network quality. Professionals should approach such situations by first acknowledging the reported issue and initiating an immediate, multifaceted investigation. This involves leveraging network monitoring tools, analyzing performance data, and correlating it with customer complaints. The decision-making process should be guided by a hierarchy of priorities, immediate service restoration, root cause identification, long-term network health, and strict adherence to all applicable regulatory mandates. This structured approach ensures that solutions are effective, efficient, and legally sound, minimizing risk and maximizing customer satisfaction. Question 14. Research into a reported intermittent degradation of voice call quality and data throughput for a specific sector within a CDMA network has led to the identification of potential congestion on the reverse link. The Network Operations Center, NOC, has received multiple subscriber complaints regarding dropped calls and slow data speeds in this area. The engineer on duty needs to address this issue promptly. Which of the following actions is the most appropriate first step to resolve the reported network performance issues? Option A. Initiate a sector reboot to clear any potential software glitches contributing to the performance degradation. Option B. Immediately adjust the reverse link power control parameters to reduce transmission power for all active users in the sector. Option C. Analyze existing reverse link performance metrics and traffic logs for the affected sector to identify the specific cause and pattern of congestion. Option D. Disable certain background data services within the affected sector to free up reverse link capacity. The correct answer is C. Analyze existing reverse link performance metrics and traffic logs for the affected sector to identify the specific cause and pattern of congestion. Explanation. This scenario presents a professional challenge due to the critical nature of ensuring network performance and subscriber experience in a CDMA environment, while adhering to specific operational guidelines. The challenge lies in balancing immediate troubleshooting needs with the potential for unintended consequences on a live network, especially when dealing with sensitive performance metrics. Careful judgment is required to select an intervention that is both effective and compliant. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation within the defined operational framework. By first analyzing existing performance data and logs, the engineer can identify the root cause of the reported issue without immediately resorting to potentially disruptive configuration changes. This aligns with best practices for network management, which emphasize understanding the problem before implementing solutions. Furthermore, this approach respects the established procedures for network maintenance and troubleshooting, ensuring that any subsequent actions are well-informed and documented, thereby minimizing risk and maintaining network stability. This methodical process is crucial for maintaining service quality and adhering to operational service level agreements, SLAs, that are often implicitly or explicitly governed by regulatory expectations for reliable service delivery. An incorrect approach that involves immediately altering quality of service, COS, parameters without a clear understanding of the impact is professionally unacceptable. This action could lead to a degradation of service for a wider group of subscribers, potentially violating regulatory mandates for service availability and quality. It bypasses the necessary diagnostic steps, demonstrating a lack of due diligence and a disregard for established network management protocols. Such an action could also lead to an escalation of the problem, requiring more extensive and disruptive remediation efforts. Another incorrect approach, such as disabling specific features or protocols without a thorough analysis, carries similar risks. This could inadvertently disrupt essential network function, leading to service outages or performance issues for other services or subscriber segments. It represents a reactive rather than a proactive troubleshooting methodology and fails to consider the interconnectedness of network components. This lack of a structured approach can lead to unforeseen consequences and a failure to meet service commitments, which may have regulatory implications. The professional reasoning process for similar situations should involve a structured, phased approach to troubleshooting. This begins with a clear understanding of the reported problem and its scope. Next, engineers should leverage available monitoring tools and historical data to diagnose the root cause. Only after a thorough analysis and identification of the probable cause should potential solutions be considered. These solutions should be evaluated for their potential impact on the network and other services, and ideally tested in a controlled environment or implemented during scheduled maintenance windows if significant risk is identified. Documentation of all steps taken and their outcomes is paramount for accountability and future reference, ensuring compliance with operational standards and regulatory oversight. Question 15. Cost-benefit analysis shows that implementing a new set of advanced CDMA features could significantly increase subscriber revenue, but initial assessments indicate potential for increased radio frequency interference within the existing spectrum allocation. Given the regulatory framework for implementing Cisco service provider mobility CDMA networks, SPCDMA, in the United States, which approach best balances the economic benefits with the legal and operational requirements. Option A. Proceed with the feature implementation immediately, relying on vendor assurances that the new features are compliant and will not cause significant interference, and address any interference issues reactively if they arise. Option B. Conduct a thorough technical study to quantify the potential interference impact of the new features on existing services and adjacent spectrum users, and develop specific mitigation strategies to ensure compliance with FCC Part 22 regulations before proceeding with deployment. Option C. Delay the implementation of the new features indefinitely until a completely new, interference-free spectrum allocation can be secured, even if this means foregoing immediate revenue opportunities. Option D. Implement the new features on a limited basis in a non-critical geographic area to gauge subscriber uptake and potential interference, without a formal pre-deployment interference analysis. Correct answer is A. Proceed with the feature implementation immediately, relying on vendor assurances that the new features are compliant and will not cause significant interference, and address any interference issues reactively if they arise. Explanation. Scenario analysis. This scenario presents a common challenge in telecommunications network deployment, balancing the need for rapid service expansion with the imperative to adhere to established regulatory frameworks. The core professional challenge lies in interpreting and applying the specific requirements of the 600-211 SPCDMA exams jurisdiction, which, for the purpose of this question, is assumed to be the United States, focusing on FCC regulations and relevant industry best practices for CDMA network implementation. The pressure to deploy new services quickly can create a temptation to bypass or interpret regulations loosely, leading to potential compliance issues, service disruptions, and reputational damage. Careful judgment is required to ensure that all technical decisions align with legal and operational mandates. Correct approach analysis. The correct approach prioritizes a thorough understanding and strict adherence to the FCC's Part 22 regulations governing cellular systems, specifically concerning spectrum usage, interference mitigation, and equipment certification. This involves ensuring that the proposed CDMA network components, including base stations and mobile devices, meet all technical specifications and have obtained the necessary FCC certifications, e.g., FCC ID. Furthermore, it necessitates a detailed analysis of potential interference with existing services, both within the operator's own network and with adjacent spectrum users, as mandated by FCC rules. Implementing robust interference detection and mitigation strategies, such as proper site selection, antenna configuration, and power control, directly addresses the regulatory requirement to protect existing services and maintain spectrum integrity. This approach represents best professional practice, because it is grounded in the legal obligations of the operator, ensuring lawful operation, minimizing risks of fines or service suspension, and fostering a reliable and efficient mobile network for consumers. Incorrect approaches analysis. One incorrect approach involves prioritizing the immediate deployment of new features and services without a comprehensive review of their impact on spectrum efficiency and potential interference. This directly violates FCC regulations that require operators to manage their allocated spectrum responsibly and to avoid causing harmful interference. Ethically, it demonstrates a disregard for the rights of other spectrum users and the overall stability of the mobile ecosystem. Another incorrect approach is to assume that existing network configurations are sufficient for the new services without conducting specific testing for the new CDMA implementation. This overlooks the unique characteristics of CDMA technology and its potential to interact differently with the radio environment compared to previous technologies. It fails to meet the professional obligation to thoroughly validate network performance and compliance before deployment, potentially leading to unforeseen service quality issues or regulatory noncompliance. A third incorrect approach is to rely solely on vendor assurances regarding compliance without independent verification. While vendors are responsible for providing compliant equipment, the ultimate responsibility for lawful operation rests with the service provider. This approach abdicates professional due diligence and could lead to the deployment of non-compliant equipment, resulting in significant penalties and operational disruptions. Professional reasoning. Professionals in this field must adopt a decision-making framework that begins with a comprehensive understanding of the applicable regulatory landscape, in this case, U.S. FCC regulations. This should be followed by a thorough technical assessment of the proposed implementation, including its impact on spectrum usage and potential for interference. Risk assessment, considering both technical and regulatory implications, is crucial. When faced with deployment pressures, professionals should advocate for a phased approach that allows for rigorous testing and validation at each stage, ensuring compliance before proceeding. Open communication with regulatory bodies and adherence to industry best practices, such as those outlined by CTIA for CDMA networks, are essential components of responsible network implementation. Question 16. Governance review demonstrates that a new feature is being considered for implementation on the existing CDMA network infrastructure. This feature is designed to enhance subscriber data management and potentially improve network efficiency. However, there is a concern that its integration might inadvertently affect the network's ability to support lawful intercept requests as mandated by U.S. regulations. What is the most appropriate course of action to ensure compliance with lawful intercept requirements before the feature is deployed? Option A. Implement the feature immediately and address any potential lawful intercept issues that may arise through subsequent network adjustments. Option B. Deploy the feature and then initiate a series of post-deployment tests to verify lawful intercept capabilities. Option C. Proceed with the feature implementation, assuming the vendor has ensured full compliance with all applicable U.S. lawful intercept regulations. Option D. Conduct a thorough lawful intercept compliance assessment by the internal compliance team during the feature's design and testing phases, verifying its impact on intercept mechanisms and data delivery. The correct answer is D. Conduct a thorough lawful intercept compliance assessment by the internal compliance team during the feature's design and testing phases, verifying its impact on intercept mechanisms and data delivery. Explanation. Scenario analysis. This scenario presents a professional challenge related to the implementation of a new CDMA network feature that has potential implications for lawful intercept capabilities. The core difficulty lies in balancing the technical requirements of the new feature with the absolute, non-negotiable mandate of maintaining compliance with lawful intercept regulations. Network engineers must ensure that any new functionality does not inadvertently create a blind spot or hinder the ability of authorized agencies to access subscriber data as legally required. The pressure to deploy new services quickly can create a conflict with the meticulous due diligence required for regulatory compliance, demanding a careful and systematic approach. Correct approach analysis. The correct approach involves a proactive and integrated compliance strategy. This means that during the design and testing phases of the new CDMA feature, a dedicated review by the network's lawful intercept compliance team is essential. This team, familiar with the specific U.S. regulatory framework governing lawful intercept, e.g., CALIA Communications Assistance for Law Enforcement Act, would assess the feature's impact on existing intercept mechanisms. They would verify that the feature does not obstruct the delivery of call detail records, CDR, call content, or location information to authorized law enforcement agencies. This approach represents best professional practice because it embeds regulatory compliance into the development lifecycle, preventing costly retrofits or potential legal repercussions. It demonstrates a commitment to upholding legal obligations as a fundamental aspect of network operations, aligning with the spirit and letter of U.S. telecommunications law. Incorrect approaches analysis. Implementing the feature without a prior lawful intercept compliance review is a significant regulatory failure. This approach ignores the explicit requirements of U.S. law, such as CALIA, which mandates that telecommunications carriers provide assistance to law enforcement for lawful intercept. Failing to assess the impact on these capabilities before deployment could lead to a situation where lawful intercepts are compromised, resulting in severe legal penalties, fines, and reputational damage. Relying solely on the vendor's assurance that the feature is compliant without independent verification is also a regulatory and ethical lapse. While vendors may strive for compliance, the ultimate responsibility for adhering to U.S. lawful intercept regulations rests with the service provider. This approach outsources a critical compliance function and fails to exercise due diligence, potentially overlooking subtle integration issues that could impact intercept capabilities. Post-deployment testing of lawful intercept capabilities, only after the feature is live, is a reactive and risky strategy. This approach introduces a high probability of non-compliance during the period the feature is active, potentially leading to missed intercepts and subsequent legal ramifications. Best professional practice dictates a preventative rather than a corrective approach to regulatory compliance, especially concerning sensitive areas like lawful intercept. Professional reasoning. Professionals in this field must adopt a risk-based, compliance-first mindset. When implementing new network features, especially in a regulated environment like U.S. telecommunications, the decision-making process should prioritize understanding and mitigating regulatory risks. This involves 1. Identifying all relevant regulations, e.g., CALIA. 2. Proactively assessing the impact of any proposed change on compliance obligations. 3. Engaging relevant compliance stakeholders early in the design and testing phases. 4. Documenting all compliance reviews and decisions. 5. Establishing clear escalation paths for any identified compliance concerns. This systematic approach ensures that technical innovation does not come at the expense of legal and ethical responsibilities. Question 17. Which approach would be most effective in proactively addressing potential forward-link power control issues in a deployed Cisco SPCDMA network to ensure optimal capacity and minimize interference? Option A. Implement broad, uncalibrated adjustments to power control parameters across the entire network when user complaints about poor service increase. Option B. Address user complaints of poor service only when they become widespread and significantly impact overall network availability. Option C. Continuously monitor key performance indicators such as FER and CINR across sectors, analyze trends, and make targeted adjustments to power control parameters based on data. Option D. Ignore power control settings and rely solely on vendor default configurations, assuming they are sufficient for all operational conditions. The correct answer is C. Continuously monitor key performance indicators such as FER and CINR across sectors, analyze trends, and make targeted adjustments to power control parameters based on data. Explanation. This scenario presents a professional challenge related to ensuring the integrity and performance of a CDMA network under evolving traffic demands, specifically concerning the efficient management of forward-link power control. The core difficulty lies in balancing the need for robust signal quality for all users, especially in a mobile environment, with the imperative to minimize interference and optimize overall network capacity. Incorrect power control can lead to dropped calls, poor data throughput, and inefficient use of limited radio spectrum, all of which have direct implications for service provider operations and customer satisfaction. The correct approach involves a proactive and data-driven strategy for optimizing forward-link power control parameters. This entails continuous monitoring of key performance indicators, KPI such as frame error rate FER, signal interference plus noise ratio CINR, and pilot pollution levels across different sectors and cell sites. By analyzing this data, network engineers can identify sectors or cells experiencing excessive power levels or insufficient power, and then adjust the relevant parameters within the base station, e.g., pilot channel power, traffic channel power control algorithms, to achieve optimal balance. This approach is best professional practice because it directly addresses the technical underpinnings of CDMA performance, ensuring that the network operates within its design parameters and adheres to the principles of efficient spectrum utilization. It aligns with the operational guidelines for maintaining a stable and high-performing mobile network, which is a fundamental requirement for any service provider. An incorrect approach would be to ignore or only sporadically address reported user complaints of poor service without a systematic investigation into the underlying network conditions. This failure to proactively monitor and analyze network performance data represents a significant regulatory and ethical lapse. It can lead to a degradation of service that violates service-level agreements, SLAs, with customers and potentially breaches regulatory requirements for network quality and availability. Furthermore, it demonstrates a lack of due diligence in managing critical network resources. Another incorrect approach would be to implement broad, uncalibrated adjustments to power control parameters across the entire network without specific data to justify the changes. This shotgun method is inefficient and can inadvertently create new problems, such as introducing interference in previously healthy areas or further degrading service in problematic ones. This approach is professionally unsound, as it lacks the analytical rigor required for effective network management, and can lead to unintended consequences that negatively impact network performance and user experience, potentially leading to regulatory scrutiny for service degradation. A third incorrect approach would be to solely rely on vendor default settings for power control without any performance validation or tuning. While default settings are designed to provide a baseline, they are rarely optimal for a specific network's unique traffic patterns, geography, and interference environment. Failing to tune these parameters means the network is likely operating suboptimally, leading to reduced capacity and potentially poorer service quality, which is a failure to meet the professional obligation of providing the best possible service within the given constraints. The professional decision-making process for similar situations should involve a continuous cycle of monitoring, analysis, and adjustment. Network engineers must establish robust monitoring systems to collect relevant performance data. This data should then be analyzed to identify trends and anomalies. Based on this analysis, targeted adjustments to network parameters, including power control settings, should be made. Finally, the impact of these adjustments must be re-evaluated through ongoing monitoring to ensure they have achieved the desired outcome and have not introduced new issues. This iterative process, grounded in data and technical expertise, is crucial for maintaining optimal network performance and adhering to professional and regulatory standards. Question 18. The review process indicates that a recent network configuration adjustment, intended to improve data throughput on the CDMA network, was implemented directly into the live production environment without prior laboratory testing or formal approval from the network security team. The adjustment involved modifying quality of service, CoS parameters that could potentially impact traffic prioritization, and consequently, security protocols. What is the most appropriate course of action to address this situation and prevent future occurrences? Option A. Immediately revert the configuration to its previous state, conduct thorough laboratory testing of the proposed changes, and then submit a formal change request for review and approval by all relevant stakeholders, including the security team, before re-implementation. Option B. Document the implemented changes and their observed impact on performance, and then proceed with a post-implementation security audit to identify any vulnerabilities. Option C. Implement additional monitoring tools to track the specific CoS parameters that were adjusted and analyze the data to confirm the intended performance improvement. Option D. Instruct the engineer responsible to document the changes and their rationale, and monitor the network closely for any performance or security anomalies. The correct answer is A. Immediately revert the configuration to its previous state, conduct thorough laboratory testing of the proposed changes, and then submit a formal change request for review and approval by all relevant stakeholders, including the security team, before re-implementation. Explanation. Scenario analysis. This scenario presents a professional challenge related to network security and compliance within a CDMA mobile service provider environment. The core difficulty lies in balancing the immediate need for network performance optimization with the imperative to adhere to established security protocols and regulatory mandates. A hasty or unverified change, even with good intentions, can introduce vulnerabilities or violate compliance requirements, leading to service disruptions, data breaches, or regulatory penalties. The pressure to resolve performance issues quickly can tempt engineers to bypass standard procedures, making careful judgment and adherence to established frameworks critical. Correct approach analysis. The correct approach involves a systematic and documented process for implementing network changes. This includes thorough testing in a controlled environment, lab or staging, to validate the impact of the proposed configuration on both performance and security. Following this, a formal change management process, which typically involves review and approval by relevant stakeholders, e.g., security team, network operations, compliance officers, is essential. This ensures that all potential risks are assessed, and the change aligns with the organization's security policies and any applicable regulatory requirements. The use of rollback procedures is a key component, providing a safety net in case of unforeseen issues. This methodical approach represents best professional practice because it prioritizes system stability, security, and compliance, minimizing the risk of negative consequences. It directly aligns with the principles of responsible network management and the need to maintain a secure and reliable service, which are often implicitly or explicitly covered by regulatory frameworks governing telecommunications. Incorrect approach is analysis. Implementing the change directly in the live production network without prior testing or formal approval is a significant regulatory and ethical failure. This bypasses critical validation steps, increasing the risk of introducing security vulnerabilities or causing service degradation, which could lead to non-compliance with service-level agreements and potentially regulatory sanctions for service disruption. Applying the change without documenting the specific security implications and potential risks is also professionally unacceptable. Regulatory frameworks often require auditable records of network changes and their security impact. A lack of documentation hinders troubleshooting, makes it difficult to demonstrate compliance during audits, and can be interpreted as negligence. Failing to involve the security team in the review and approval process, even if the change is intended to improve performance, is a critical oversight. Security is an integral part of network operations, and changes that affect network behavior can have unintended security consequences. Excluding the security team violates the principle of shared responsibility for security and can lead to the introduction of vulnerabilities that the security team would have identified and mitigated. Professional reasoning. Professionals in this field must adopt a risk-based approach to network changes. This involves a continuous cycle of assessment, planning, implementation, and review. Before any change, engineers should ask, what are the potential impacts on performance, security, and compliance? Is there a documented procedure for this type of change? Who needs to be consulted and approve this change? What is the rollback plan if something goes wrong? Adhering to a robust change management framework, which is a cornerstone of IT and network operations best practices and often a requirement for regulatory compliance, is paramount. This framework ensures that changes are controlled, understood, and authorized, thereby safeguarding the integrity and security of the network. Question 19. The analysis reveals that a CDMA mobile network operator is experiencing suboptimal spectrum utilization in several key urban sectors, leading to capacity constraints and potential service degradation during peak hours. The network engineering team is tasked with improving efficiency. Which of the following approaches best addresses this challenge while adhering to regulatory principles of efficient spectrum management? Option A. Systematically analyze network performance data, including center, traffic load, and handoff statistics, to identify specific areas of inefficiency and implement targeted adjustments to antenna parameters, power levels, or sector configurations. Option B. Prioritize immediate reallocation of the affected spectrum bands to a newer technology, assuming it will inherently offer better efficiency, without a detailed impact study or regulatory consultation. Option C. Disregard interference reports originating from adjacent network operators, focusing solely on internal network metrics. Option D. Increase the transmit power of base stations in the identified sectors to overcome perceived signal weaknesses and boost capacity. The correct answer is A. Systematically analyze network performance data, including center, traffic load, and handoff statistics, to identify specific areas of inefficiency and implement targeted adjustments to antenna parameters, power levels, or sector configurations. Explanation. The analysis reveals a common challenge in CDMA network deployment, ensuring efficient spectrum utilization while maintaining service quality and adhering to regulatory mandates. The professional challenge lies in balancing these competing demands. A service provider must not only implement the technology correctly, but also operate within the legal and technical boundaries set by regulatory bodies. This scenario requires a deep understanding of CDMA principles, radio frequency management, and the specific regulations governing spectrum use in the relevant jurisdiction. Careful judgment is needed to select an approach that maximizes efficiency without compromising compliance or user experience. The correct approach prioritizes a systematic, data-driven method for identifying and resolving spectrum inefficiencies. This involves leveraging network performance monitoring tools to pinpoint areas of high interference or underutilization. By analyzing key performance indicators, KPI, such as signal-to interference plus noise ratio (SINR), traffic load, and handoff failures. Engineers can identify specific sectors or cells that are not operating optimally. Implementing targeted solutions, such as adjusting antenna downtilt, power levels, or sector configurations, based on this data, directly addresses the root causes of inefficiency. This approach is best professional practice because it is grounded in objective network data and aligns with the regulatory objective of efficient spectrum use, which is often a condition of spectrum licensing. It demonstrates a commitment to operational excellence and responsible resource management. An incorrect approach that focuses solely on increasing transmit power without a thorough analysis is professionally unacceptable. This is because it can lead to increased interference to adjacent cells and potentially to other services operating in nearby frequency bands. Such an action could violate regulatory limits on out-of-band emissions and power levels, leading to fines and potential revocation of operating licenses. It also fails to address the underlying cause of inefficiency, which might be poor sector planning or interference from other sources. Another incorrect approach that involves ignoring interference reports from neighboring cells is also professionally unsound. This demonstrates a lack of inter-carrier cooperation and a disregard for the broader impact of network operations on the overall spectrum ecosystem. Regulatory frameworks often mandate a degree of cooperation to prevent harmful interference. Failing to investigate such reports can lead to escalated interference issues, service degradation for subscribers of other networks, and potential regulatory sanctions. Finally, an approach that involves reallocating spectrum resources to a different technology without a comprehensive study of the impact on existing CDMA services and regulatory approvals is premature and risky. Spectrum reallocation is a complex process that requires detailed planning, technical validation, and explicit regulatory permission. Implementing such a change without due diligence could disrupt existing services, lead to non-compliance with spectrum licenses, and incur significant penalties. Professionals should adopt a decision-making framework that begins with understanding the problem through data collection and analysis. This is followed by identifying potential solutions, evaluating them against technical feasibility, operational impact, and regulatory compliance, and then implementing the most appropriate solution with thorough testing and monitoring. Continuous performance monitoring and adherence to regulatory guidelines are paramount throughout the network lifecycle. Question 20. Benchmark analysis indicates that a service provider is planning to deploy a new CDMA mobile network in a densely populated urban area. To ensure seamless integration and avoid potential operational disruptions, what is the most critical initial step to undertake regarding the radio frequency environment? Option A. Conduct a comprehensive site survey and spectrum analysis to identify existing radio frequency activity and potential interference sources. Option B. Rely on the inherent interference cancellation capabilities of the CDMA technology to manage any potential signal conflicts. Option C. Proceed with the network deployment, assuming that the new CDMA signals will naturally find clear spectrum channels. Option D. Initiate the deployment and address any interference issues that may arise reactively after the network is operational. The correct answer is A. Conduct a comprehensive site survey and spectrum analysis to identify existing radio frequency activity and potential interference sources. Explanation. Scenario analysis. This scenario presents a challenge in network deployment where a service provider must integrate a new CDMA network while adhering to specific regulatory mandates concerning spectrum usage and interference mitigation. The professional challenge lies in balancing the technical requirements of implementing a high-performance mobile network with the legal and operational constraints imposed by regulatory bodies. Failure to comply can result in significant penalties, service disruptions, and reputational damage. The need for precise adherence to spectrum allocation and interference avoidance protocols is paramount, requiring a deep understanding of both the technology and the governing regulations. Correct approach analysis. The correct approach involves a thorough site survey and spectrum analysis to identify any existing licensed or unlicensed transmissions within the proposed operating frequencies. This proactive measure ensures that the new CDMA network's deployment will not cause harmful interference to other services, nor will it be susceptible to interference from them. This aligns directly with the principles of responsible spectrum management, core tenet of telecommunications regulation. By conducting this analysis before deployment, the provider demonstrates due diligence and a commitment to regulatory compliance, minimizing the risk of future disputes or enforcement actions. This approach prioritizes adherence to the specific regulations governing CDMA spectrum usage and interference, as mandated by the relevant regulatory framework for the exam's jurisdiction. Incorrect approach is analysis. Deploying the network without a prior site survey and spectrum analysis is a direct violation of regulatory requirements for spectrum coexistence. This approach risks causing harmful interference to other licensed users, leading to regulatory sanctions, fines, and potential revocation of operating licenses. It also exposes the new network to potential interference, degrading service quality and user experience, which is also a breach of service level expectations implicitly governed by regulatory oversight. Assuming that existing spectrum usage is negligible without empirical data is a speculative and unprofessional approach. Regulatory frameworks are designed to prevent such assumptions, requiring verifiable data to ensure compliance. This assumption bypasses the necessary due diligence and can lead to unforeseen interference issues that are costly and time-consuming to resolve, and which would be viewed as a failure to meet regulatory obligations. Relying solely on the CDMA equipment's built-in interference mitigation features without understanding the surrounding RF environment is insufficient. While these features are important, they are designed to manage interference within a known spectrum context. Without a pre-deployment analysis, the provider cannot guarantee that these features will be effective against all potential interference sources, especially those operating under different regulatory licenses or in adjacent spectrum bands. This demonstrates a lack of comprehensive understanding of the regulatory landscape and a failure to implement a robust interference management strategy. Professional reasoning. Professionals in this field must adopt a risk-averse and compliance-first mindset. The decision-making process should begin with a thorough understanding of the applicable regulatory framework. Before any technical implementation, a comprehensive assessment of the operational environment, including spectrum usage, is essential. This involves planning and executing necessary surveys and analyses. If potential conflicts are identified, the next step is to develop mitigation strategies in consultation with regulatory guidelines and potentially with affected parties. Documentation of all analyses, decisions, and mitigation efforts is crucial for demonstrating compliance and for future reference. This systematic approach ensures that technical objectives are met within the bounds of legal and ethical operational standards.